Hi, it's been a long time and thank you so much for all your support. So this time I'm back, and then for today's video, we will be talking about the intuitive and the formal introduction of a derivative of a function. So guys, thank you so much for all your support. So if you are new to my channel, please don't forget to subscribe, because hopefully I would be continuing with this channel moving forward. Okay, so let's start now. So when we talk about derivative, it tells us that there is a rate of change, or derivative means rate of change. So meaning to say that if a function, let's say f of x, its derivative exists at x sub 0, meaning to say that there's a rate of change of the function f of x at a point x sub 0, f of x sub 0. So to see this clearly, let's show the geometric interpretation for that. Let's say this is our graph, assuming I have a perfect drawing here. And then this is our curve. So let's say we have a point p sub 0, and then we have a point p. Okay, and then let's say the coordinates of p sub 0 is the x sub 0, and suppose, let's say, the the horizontal distance of the point p and the p sub 0 here is, let's say, h, this one until here. So you project a line perpendicular to the x-axis. So let's say this is x sub 0 plus h, and then the corresponding ordinate for that is f of x sub 0 plus h. So suppose we have this line connecting these 2 points. So let's say this is the line connecting p sub 0 and the p. So assuming this is very straight line, I have perfectly drawn it. And then with that, back on our discussion for the slope of a line. So to solve for the slope, we have, let's say we label this as L. So the slope of L is equal to f of x sub 0 plus h minus f of x sub 0 all over x sub 0 plus h minus x sub 0. So in this case here, we're actually solving the rise over run. And then if we simplify this, we have f of x sub 0 plus h minus f of x sub 0 all over h. Now, if you're trying to observe that as h tends to 0, so meaning to say that these ones move here, so your graph of a line changes like this one until this one, until it goes like this. Okay, so assuming that's the perfect representation. I mean, I perfectly draw it. In other words, the limiting position of your line is the tangent line. So this is not a tangent. So meaning to say that starting from being a secant line, this goes to become tangent line. Meaning to say that there is a change of the positions. If we take the limit of this here as h approaches to 0, so we have now the new form, which is f of x sub 0 plus h minus f of x sub 0 all over h as h approaches 0. Okay, this is the same as the limit of m sub l as h approaches 0. Meaning to say that if we take the limit of the slope here, we're actually getting the derivative of a function. So basically, this is now the derivative of a function. So with this, we will formally present the formal definition of a derivative of a function. So a function f of an independent variable, let's say x, then the derivative of f at x sub 0, denoted by the symbol. So this is derivative of f at x sub 0, is given by this formula. Okay, of course, provided this one, I mean the limit of this exists. So if it exists and then you're able to get that, then that's actually the derivative of a function at x sub 0. So if f prime of x sub 0 exists, then f is said to be differentiable at x sub 0. And then if the function is said to be differentiable at every point on the domain of f, then entirely we call that as the f is differentiable. So with this definition, we have now the three-step rule for taking the derivative of a function. So first step is you simplify the f of x plus h minus f of x. And then second step is you divide this f of x plus h minus f of x by h. So meaning to say that we have to solve this expression here, provided your h is not 0. And then number 3 is that you evaluate the limit as h approaches 0 of this expression. So provided that the limit exists, then we are actually getting the derivative of a function of f at x sub 0. So let's consider, for example, find the derivative of f of x equals x squared. Okay, so we use the three-step rule. Rule number 1, we have to solve the f of x plus h minus f of x. So meaning to say that we have f of x plus h minus f of x. We just have to plug in this variable to the x squared. Okay, so what we have now is x plus h squared minus x squared. And then if we simplify this, we have x squared plus 2xh plus h squared minus x squared. Our resulting expression would be 2xh plus h squared. What do we do in the second step? So the second step says that we have to divide this expression by h. So meaning to say that you have f of x plus h minus f of x all over h. But then this numerator, we've gotten this already as this. So we have 2xh plus h squared all over h. If we simplify that, we end up having 2x plus h. So lastly, we will get the limit of this expression as h approaches 0. We'll be getting the limit of 2x plus h as h approaches 0. So in this case, the variable is h. So we have 2x. So therefore, the derivative of our x squared is now 2x. Okay, so let's try another example. So let's say our f of x here is 8 minus x cubed. First step is we solve for f of x plus h minus f of x. And so we have this one, 8 minus x plus h cubed minus 8 minus x cubed. Okay, so if we simplify this, we will get 8 minus x cubed minus 3x squared h minus 3x h squared minus h cubed minus 8 plus x cubed. So if we simplify it further, we would end up having negative 3x squared h minus 3x h squared minus h cubed. For the second step, we have to divide f of x plus h minus f of x all over h. So that becomes 3x squared h minus 3x h squared minus h cubed all over h. And so we have minus 3x squared minus 3x h minus h squared. For the last step, we will take the limit of f of x plus h minus f of x all over h as h approaches 0. So this becomes the limit of this one minus 3x squared minus 3xh minus h squared. So the answer is negative 3x squared. So therefore, the derivative of your f of x is equal to minus 3x squared. That's it. And that's all for today's video. So if you have any questions or clarification, please don't forget to comment down there so that I would know and we can discuss on that. And then see you next video.